MAF stands for mass airflow. The MAF sensor is an electronic sensor used by the engine management system to measure the amount of air entering the engine. This information is extremely important because an engine needs the correct balance of air and fuel to produce efficient combustion. The MAF sensor sends an airflow signal to the ECU, or engine control unit. The ECU uses this information, together with data from other sensors, to determine how much fuel the engine needs. So, in simple terms, the MAF sensor tells the ECU how much air the engine is breathing. If the sensor reports incorrect airflow, the ECU can make incorrect fueling decisions, which can affect engine performance, fuel economy, emissions, and drivability. So where can you find the MAF sensor? On many vehicles, the MAF sensor is installed in the engine's intake system, usually between the air filter housing and the throttle body. Air first enters through the air filter. The filtered air then passes through the MAF sensor. After that, the air continues through the intake duct toward the throttle body and eventually into the engine. Because the MAF sensor needs to measure the air entering the engine, its position in the intake stream is very important. However, the exact design and location can vary depending on the vehicle and engine. Some vehicles also integrate the intake air temperature sensor into the MAF assembly. Now let's look at how the MAF sensor actually works. One of the most common MAF designs is the hot wire or hot film type. Inside the sensor is a very small sensing element positioned in the airflow. The sensor's electronic circuit heats this element. When air flows past the heated element, it removes heat from it. The faster and greater the airflow, the greater the cooling effect. The sensor electronics detect this change and adjust the electrical current needed to maintain the sensing element at its controlled temperature. The electrical information is then converted into an output signal that the ECU can interpret as airflow. So the basic principle is simple. More airflow, more cooling, the sensor electronics compensate, the ECU receives a corresponding airflow signal. This allows the engine computer to determine how much air is entering the engine and adjust fuel delivery accordingly.